One way that we can find the slope of a line is using a graph. And that's what we did in the previous example, where we graphed something out and then we found the rise and the run between 2 points that are along the line. Another way that we can do that is by using a formula. Okay, and so the formula is to be used if we can't graph, or if we're just given 2 points and we're not able to graph it out, or if you find it a little bit easier, you can use it at any time. So let's remember first that the slope is rise over run, which is a change in y over the change in x. Okay, so that's one way to kind of look at it. It's how much is the y value changing over how much is the x value changing. Now let's find the slope of a line which goes through the points 2, 4, okay, and -1, 6. Now, just as a quick little reference guide, I'm going to draw those out really quickly on a very small graph, which in no way is meant to be to scale, and in no way is going to be accurate either. But just in general, let's look. 2, 4 would be roughly there, and -1, 6 would be roughly there. So this line is going to look kind of like that. Kind of. Okay. Now again, it's rough, but we can see that the line is going down. So we're going to have a negative slope. So that's one thing to take a look at. Now our formula looks like this. M is equal to y2 minus y1 over x2 minus x1. Okay, that's our formula that we're going to be using. This is our slope formula. Okay, and so in that point there is figuring out, or that's going to help us to find the rise and the run. y2 minus y1 is going to tell us the change in y. So what's the second y value? What's the first y value? And it's going to how it changes. And then the bottom is going to tell us the change in x, which is going to go from our second x value to our first x value. Now, just as a quick little side note, we could do this in any order. It doesn't matter which one's x, which one's 1, and which one's 2. But if our first one, if the one on the left is number 1, okay, so we're going to call that number 1, and this one number 2, it's just going to make it a little bit easier. That way our bottom's never going to be negative, which is a nice thing for slope. But let's look at that here. So this is point number 1. So this is going to be x1, and that's going to be y1. So that's our first x value. This is our second or first y value. This one here is going to be x2 and y2. This is going to be our second x value and our second y value. Okay, and this is going to then tell us our slope. It's going to show us how much is our y changing and how much is our x changing. When we plug that in, okay, m is y2 minus y1, so we're going to do 4 minus 6. And then x2 minus x1, so we're going to take x2 and x1, and then 2 minus -1. And this is going to give us our slope. Okay? Now, when we do something like this, it's very important that we understand adding and subtracting of negative numbers, because we'll often get that. And it's okay to have negatives. That's very much okay. 4 minus 6 is -2. 2 minus -1 is actually +3. Now, if you don't trust me on that, 2 minus -1 is +3. Remember, when we're subtracting a negative, we add, so we're actually going up. Okay, we're subtracting negative, we're trying to get rid of negatives, so we're actually adding a positive. So this is +3. Now our slope is -2/3. The negative is really for the whole thing. If we divide a negative by a positive, the whole thing is negative. So if the top is negative, it's just the whole thing is negative. That's how we can understand it. And so when we do that there, -2/3 is our slope. That means we're going down 2. The negative represents down, and then over 3. And so this becomes our slope, okay? Down 2 and over 3. If we have a positive, that means we're going up, so that's a rise. If we have a negative, that means we're going down. So we're going to go down 2 over 3, and that's going to be our slope. And you'll notice that is a negative slope as it goes down.